Okay, so welcome everyone. So we're going to start the second part of the course, and this is going to be project focused. And we'll start off today with Amendra. He said he will do this little 7 minutes of tweet classification from this Git book we had. So, and then I'll tell you guys kind of the plan for the rest of the semester.
I don't know how many of you remind, in the last class we had this how to classify tweets, like in the live. Most of the thing I am using what he has already used to download tweets and like transfer like that tweets from raw tweet to give some structure, like to put in some MySQL, and after that I have made some classifier looking the videos which they have provided. The guy who has already done, I have just implemented that. It's not my theory like how it works. I'm just using the theory and I just written some code in Scala. That's it. It's shipped in there. Okay.
I hope the notebook is still in place.
There is an error.
So right, so you have it. So you have it in so you just want to run that same notebook, right?
Yeah.
So
It's
so it's yeah, it's in SDS 2.2.
no import in there.
So I think it should be just SDS -2. Let's try it. Okay.
And you can ask me question if you have them. I will try to answer it. But okay, it looks like it's working. And after this, we need something so we can download to it. You just need to use your credential to download to
You're
it.
brave, you know.
Yeah, but this is not my real tweet. I just make some fake account. It's fine. Now we'll start like download to it, and this is the directory where I want to download my tweet. Just to make sure it's empty, and this is where I'm trying to create like the sliding windows when you download to it. I'm just repeating what we did like last lecture.
Oh, by the way, the sad news is that Spark streaming context is obsolete. So anyway, I'll get you guys into the latest thing called structured streaming. So
yeah,
this is just 1 year old. It's still good.
And we want to have that tweet in JSON format, so I'm just using Google JSON for that. And once we have everything, then I'm just trying to this is just to download tweets. And once we have created a framework, now we can just say start. I need to start downloading tweets. Let's wait for a few seconds and we can see how many tweets are downloaded. Okay, it's downloading. In the meanwhile, I need to change a bit in this TTDF function. It's fine if I change it.
Yeah.
Because I think you don't have this language field in this TTDF.
Yeah, probably not.
So I just made added one field so that I can get that language also in that in my tweets. What I have done is it's not a lot. I just because when you do the classification, we are classifying with respect to the language, so we need this field just to. There is another function where you do it this with the hashtag, but we don't need this, so it's fine. We don't change. If you want to change, you can just put it that field there also. Then it works for. Okay, that's it.
Yeah.
This one?
No, I think it's the one to the left. No. Sorry. I'm sorry. Try to keep the number of tabs to this one, right?
No,
it's the one before here. One.
No.
Oh no, you actually just.
You did? I pressed control.
Yeah, you just.
Okay. Hope it's running. Okay, we have 1,000, more than 1,000 tweets. It's fine. Like, it's better like if we have lots of tweets, then the classifier will be really good because it can train on lots of data. But this is fine for ours. There might be some tweets which are misclassified because the data set what we are using to train that our model is really small, like 1,000 tweets. It's better when you have a lot, but I think it's enough. Like 1,000 tweets are also enough. The guys who made the video, they had like million of tweets and their classifier was really good. But in our case, we don't have lots of time and he just gave me 7 minutes, so I have to.
No, okay, yeah, but for the project we can do a lot more.
Yeah, it's
so
like,
we have a bigger shard as well beyond the community edition.
But if you want to make some model, like it's always good to train on a big data set, so it will be really like the accuracy will be really good. Okay, we have 700, it's fine. Now we are just stopping to like to stop downloading to it. Okay, it should not be. Okay, we have 1800, more than 1800 tweets. And this is the function which I have just changed, make some small changes. This one is like to change the tweet, like to give a structure to a tweet, like because it's in JSON and we want to put it in some table so we can make some queries. And I just added one field language because he hasn't written language, and I just want to show why I want to put the language there. I have to change it, right?
I think that's okay.
It's okay?
Yeah, that's the
okay,
right.
It's working. Okay, now we have that function, and this is the directive where our tweets are downloading, and you can just change the date. You can put your date like today's date. So because we are downloading with respect to the current date, when we make the script to download here up, so it will be in current date folder, and I just put start so I get like everything because it's downloading in different interval, and I'm gathering everything in different folder. Okay, now it looks like we have some Spark table, and I'm creating some view so I can do my SQL queries, and it's created, and now okay, we can see there should be some tweets. Okay, we have some tweets, and this is live, like people are tweeting and we are getting here, like we have downloaded that live tweet. Just to check like what kind of language we have in our tweet, like okay, there are like 626 English tweets, and because our classifier is making a cluster with respect to the language, and if we don't have that field language in that when we make a structure, then we might have got error. So I just put that field in that function. Now we can see like we have tweets, we have the language, and we don't need everything from that tweet table. So I'm just extracting like tweets, so we can make a model with respect to that tweet text and make our classifier. And I just extracted text tweets from the table. From here, machine learning will start. Like I'm using KMeans for clustering. I don't know how many of you are aware of KMeans. I don't have that. KMeans.
We kind of did KMeans, right?
Right. Yeah, he had other text. It's just making clustering with respect to the character of the data set what we are providing, and it's doing lots of this. You just pass the number of cluster and it will make a centroid of that cluster and just put like new feature or new data in that cluster. That's the basic what it needs to. Okay, now this is we need to create some features like feature vector for machine learning. So we are taking that tweets and we want to represent that tweet in some mathematical format. So we are converting that text into some mathematical format. And in this case, the guys who has made this classifier, they are using n-gram, but you can use lots of other features. Like they are using bigram character, but you can use anything. Like if you want to classify tweets with respect to language, you might have like some dictionary saying, okay, if it looks like this could be English. If the text looks like this, you can make your own dictionary also. But here they are just using bigram. And once they have the bigram, then they are creating this hashing that feature vector in 1000 character feature vector, 1000 length feature vector.
So it looks like it's going modularly, right? So
yeah, it takes it's tweet. Like for example, there is one tweet, and it's calculating how many times the bigram is in that text, and it might not be like 1000 length, but then they are hashing into this 1000. It doesn't matter if there are lots of zeros, then they might convert into something else. We can see how the feature vector looks. And since KMeans is like we are doing machine learning modeling, KMeans will use lots of this time the feature vector. So it's good to. I think this is where this RDT things comes. Like it's good to cache it, so it will be really fast. Then so we are caching that feature vector into some vectors, and we can see how many vectors are there. Okay, we had like 1800 something to it, and the vector we got is like 1863. And we can see like how the vectors look like. Okay, the vectors look like this: 50, 53, this. But actually, the text it was converted into this feature vector, and it was hashed. So it's not the actual frequency; it's a hashed thing of that tweet. This is just a one single tweet. Okay, now we have created feature vector. We have we know that we have imported machine learning thing, KMeans. Now we can start building our model. Here what we are doing, like we are taking that our feature vector, what we have created, and we want to do 10 cluster. We are creating 10 clusters. You can choose how many clusters you want. But there is also some algorithm where it will choose the optimal one, but here we are just passing 10. This is not the ideal how you do clustering. You can the more you should build some model that will choose the cluster by itself, but here we are just passing 10, so it will create 10 cluster. And now we are taking some tweets. In this case, we are taking 100. Now we want to cluster these 100 tweets because we have already built a model here. Here we have already built a model. Now we want to like it's like a now we are testing if our model is it's good or not. We just take like 100 tweets from that 1800 tweets, and now we are doing this clustering here with that 100 samples. Now we can see like our cluster, like in cluster 0. You can see it's with respect to language, how the text looks like. Okay, cluster 0 is like looks like Japanese, and cluster 1 is okay. I don't know what it is. Okay, Arabic. Looks like Japanese and Arabic, because we just took like 1800 to it, so it's not so good. The classifier is not so good, the model, but looks like it's pretty good. Like Japanese cluster 2 has Japanese, 3 is empty, 4 is empty, and 6 it looks like English. Yeah, it looks like English, and 7 is empty, and 8 is Japanese. Okay, now we build a model and we tested how it looks. Now we can save that model and we can reuse that model like whenever we want. I'm just saving that model so I can use that model to classify new tweets. Okay, now the thing is what we can choose one cluster. So if new tweets come, then if we can just classify that tweets if new tweets belong this cluster or not. Did you guys get me? What we are trying to do now? Now we want to do like okay, we are getting some tweets. We'll download tweets, and I just want to show those tweets which belong to the specific cluster. In this case, we can define the cluster name. That there are like 10 clusters. Now I want to download tweets and I just want to show that tweet if that tweet belong to this specific cluster that I want. Because there are like 10 clusters and some of the clusters are just Japanese text, just some of them are English, some are Arabic, this kind of text. But now we just want to download live tweets and just show the tweets that belong to the specific cluster that I want. That's the goal of the whole the project, what they were doing, this guy was doing. So we can now pick a cluster like whatever cluster we want. For example, cluster 8, it looks like Japanese, or 6. Which cluster should we choose? Think 6. Okay, let's see how many data we are in. Okay, 6 has lots of English tweets and looks like Spanish also, but at least it will not get. We can try. The guy in the video they have done for Arabic because Arabic is so different from other languages. So the classifier, the result what they got was really good. But in our case, we don't see any Arabic tweets here, like in any cluster. Looks like people are not tweeting any Arabic tweets now. So, but we can try with the cluster 6. You just have to change, like put the cluster name here, 6. Then you have that, and it's doing now. It's downloading tweets, and it's just showing tweets if it's belong to cluster 6. Yes, it's live, like it's going now, and it looks cool when it scroll itself. But I have to scroll myself. Like, but you see, like it's good, like it's working.
So it's displaying all the tweets that could belong to
Cluster 6, yeah. It's like it's downloading to it. It's doing classification. If it belongs to cluster 6, it's displaying. Otherwise, it's not displaying. And you can do lots of things on this one. I have just said like, okay, just download to it and just show me the one if it belongs to cluster 6. And you can just stop it and you can change it again here, and you can just that's classification works.
Yeah, that's really good.
Yeah, I just implemented what the guy has done. That's it.
Well, that's really good. Thanks.
Yeah.
Are there any questions
questions?
for Amanda?
Thank you.
Yeah, so I mean, so you're not going to officially take this course second?
No, yeah, I will not be here from next week, so
Yeah.
I might take it next year. Do you have it next year?
I have no idea even if I'll be in this country next year.
Okay.
Way far in the future.
Yeah,
But
but it looks cool. Like I used to work in R, and you cannot do this kind of thing in R. It's live. You are seeing result once you get it, and it's so fast. This RDT thing and Apache Spark.
Yeah, I mean, so one couple other things I think would be, first of all, I'm very happy that you're able to, basically creatively plagiarize code now and put it and make it your own. And that's important skill. That's one of the main things about this course. And you understand what's going on and you can actually build on it. So, for example, there was a 2016 Spark Summit talk where these guys take this huge Amazon dataset and train a sentiment analyzer.
Yeah.
And then they do exactly the same on sentiments. So they just sort of want to know the sentiments. And even what you've done here, for example, if you have a slightly larger data set and you run this for a few hours, then you can have a language-specific bigram model. So for each language, you can start clustering by language. Or in fact, in the public stream, you can only select English, for example, and then start exactly doing the same code on that, right? And the other thing, which I haven't done yet, but you guys should be able to figure it out, is streaming KMeans. So streaming KMeans, see, because here you've trained your model on the static 1800 tweets, but streaming KMeans allows you to basically allow the cluster centers to vary in time. It's really cool because you can basically, because what is the cluster center now is going to change, and you have like a window parameter and some kind of memory parameter, how quickly you forget the previous centers, and so that's another, so you almost have like a kind of a branching process on the centroid space. What else? I think this is a really good notebook for anyone who wants to, continue deeper into Twitter. So let me maybe we should stop the streaming job because Yeah, I think you can just cancel because it's yeah, just hit that. Sure. Good. So I'll put this notebook as part of the whatever student.
Yeah, I have tried to document it, but I don't know how to do it.
Yeah. Good, thanks. Okay, so while we are in the sort of tweet stuff, I wanted to share something else with you guys. Yes, so what I thought would be good to do is I'm going to do a project in my own course. Maybe weird, but I thought it's a good idea because I don't quite know how we're going to do this. So I have some interests, and this is with one of my current master's student. He just finished and got a job, Joachim, and Ivan from New Zealand. So I'm going to explain to you guys what my project is, where I am, what I plan to do, maybe 5 minutes. And then we can, what I would like, you guys to do is to maybe present after Fika a little bit. You don't have to do it on a notebook. It can be more dynamic. I want you to basically start making your own little notebooks. You can do it from your community edition, publish it, and then, basically update everyone on what your plans are and what you plan to do next week. And so maybe every week we can spend an hour or so on sort of project updates, okay, for each team. Does that sound good? Because why I need some kind of feedback to change the syllabus at the right time, right? Because I don't know how many of you really need deep learning or structured streaming or whatever. Okay, so here's my project idea. This is sort of work in progress. So my project title is Where Am I in the Twitterverse? So my main objective is to allow a user in a social media platform. I'm going to focus on Twitter because it's convenient and legally easy to deal with, to become more aware of her or his place in some kind of population ideological tree, something we can formalize mathematically. So every leaf of this tree will be a user in the Twitterverse, and you yourself will be one of these leaves, and it's a huge tree. And it generalizes, it refines this notion of echo chambers or filter bubbles. Have you guys heard of these ideas in newspapers and stuff? It's a hot topic these days, right? So this population ideological tree is a mathematical generalization of echo chamber or filter bubble because it allows atomic separation. So you could be, for example, in your own echo chamber. You can retweet yourself to the extreme, but you may be, if the tree has a lot of clades, then they could be all different echo chambers and different, pairwise distances from one another and so on. Okay, so what is my main outcome is I want to use the project to build better insights into sort of current affair questions, like how does news spread today? It's a very interesting question. And I, of course, in a math department, so I want to use mathematical models of such phenomena, all the way down to very detailed combinatorial stochastic processes, which are partly motivated by making these little omegas in probability space. So you guys know probability space, right? Well, of course. Okay, it's not a big deal, right? It's just a high-level probability space is an axiomatization by Kolmogorov, right? So he basically, now it's formalized as a triple. So you have some measurable space X, okay, so something you can measure, and then you have some sigma algebra on it, some collection of events in that measurable space that satisfy some convenient properties. And then there is some family of probability distributions or measures on that space, right? And typical problems in science and engineering are decision problems. that come out of this framework. So what's missing mathematically today for a lot of these problems is we don't have the atoms, the smallest measurable unit. For example, who transmitted what to who, how, what was the exact context. So this gets very detailed, right? So of course, engineers are doing amazing things on one extreme, and there are companies like Twitter and Google making lots of money and really affecting things. But they're also very far from a mathematical formal representation of it. That's sort of my main motivation. And of course, I will build some kind of open source code. So this is the sort of commercial or motivation. Even for writing grants, you need to motivate your audience, right? So my motivation is mainly I want to build open source tools that will allow anyone to shed light on their own historical insights in their own social media feeds, right? How have they been influenced? Because these population trees and actually more generally forests, they evolve in time, right? Because what usually people change, right? So that's my main motivation. Now, last week, my favorite article was about Russian bots. I don't know, there's some Russians here. I mean, America's obsessed with Russia and vice versa. So if you go to this, should try to keep this brief, but if you go here, there's this Twitter's list of 2,752 Russian trolls, and Twitter publicly posted this, right? So if you go to the 65-page PDF file, you get this list of user ID and handle. And so, okay, of course, Twitter banned this, right? So if you read through this, they tell you, to ban these accounts. I don't know how they found it exactly, okay? But let's say this is public. Let's say this is Russian trolls. So now, what I want to basically, okay, I doubly got this file. Okay, I got this PDF, and then I try to do some, pull out the CSV out of it, and it was not easy. I asked Tilo for help. Tilo did this, I don't know, maybe 10 minutes. So he gave me a CSV file, right? Because it was not straightforward going from the PDF. But Tilo said he'll explain how he did it. So then I have the CSV file now. So I just downloaded the CSV file, and I basically put it in the distributed file store, and I have a very simple bot ID. So I have a little data frame with the IDs of these troll accounts and the screen names. So this is exactly where I am, and I spent maybe half an hour of my time doing this so far, and Tilo helped, so otherwise I would have spent a lot more than half hour. So where could I go next, right? So I'm really interested in whether these bots affected, US 2016 election, or more interestingly, whether these bots affected my own, did these bots influence my own historical status updates, right? Status updates is Twitter speak for anything you do in Twitter, right? So I'm not very active in Twitter. I kind of use it like a place to do random nonsense. I follow all kinds of extremist groups, so it's just an experimental station. But I don't know if I accidentally retweeted someone that was one of these bot accounts or replied to them or whatever, right? So I can do this. And this is actually a notebook that we haven't really gotten into. So we will fill this up if needed. So this is the REST Twitter notebook. There's a lot of code I could put in here. Because you just, Indra was talking about the streaming Twitter stuff. There's a whole representational state transfer API that allows you to go into historical timelines of anybody in Twitter. So I can get up to 3,200 status updates of anyone in Twitter using this, which means I can not only ask my own history up to 3,200, which will take me since I started my account because I'm not that active, but I can ask if any of those people in my timeline are these 2,700 accounts. I can also ask, I can do a breadth first expansion. I can take some random sample of people in my history and then ask if any of go into their timelines, right? And then ask if any of them, interacted with these bots. And I can kind of repeat this process. So I can find out, what is the, so with graph frames thrown on top of this, I should be able to find out who are my closest, say, retweeter of a retweeter who had an interaction with one of the bots, for example. Okay. That'll allow me to formalize my influence by these Russian trolls, supposedly, right? So I mean, this is something I could do, for example. Right? I don't know, and I also have data set from the U.S. 2016 election. I have about 22 million tweets I've saved in S3. So because these were tweets that were following the presidential candidates, so I can simply do a join. That's probably the first thing I'll do. Just a join of all the bot accounts, posted bot accounts, and see if people who are so many retweets away from Trump versus Hillary, if they've been affected by these bots, right? And then I can do other things, right? I can do hypothesis tests and so on. So that's my plan. Well, let's see how this goes. And I believe Joachim will do the project presentation for my project because he's working in Stockholm now, but I think he said he'll come in January to do the presentation. And in his project, he was studying the UK election, post-Brexit UK election, and building ideological population trees for politicians and bloggers. Okay. So let me get into this one. So I think this is enough before Fika. And I guess after Fika, what I would like is like a open, discussion. We can start writing on the whiteboard and put different people's projects together. Okay. So you guys have learned to. Okay. So this is just going back to a notebook now. So you guys have learned to parse structured texts, unstructured texts, JSON files. The other main thing we haven't parsed is XML, right? XML is extended markup language. So let me try to go to the community edition. So and again, this is another project idea if someone wants to continue. Maybe Tilo will do something on this as well. Okay. So what is XML? Do people know what is XML?
It's a semi-structured data saved in order to be readable by a machine and a human being.
Yeah, sounds good. I just, yeah. So anyway, this is
almost all websites use it for JSON, something like that.
Yeah, exactly. So that's literally what the first paragraph in Wikipedia says. I think it's extensible markup language that defines a set of rules for encoding documents in a format that is both human readable and machine readable. Okay. There's a lot of philosophies about XML versus JSON. Let's be kind of agnostic here about these things. The fact is a lot of stuff in digital humanities, which is a hugely growing subfield of data science, or is all in XML. It's heavily in XML. So you need to really understand XML. And this is kind of how it looks, right? You start some whatever question, you end a question, and it looks very much like HTML, which is what is that? Hypertext Transfer Protocol, markup language for hypertext. This is even more. Okay, so I'm not going to go too much into this because I'm very focused on just starting to parse directly this data set. So this data set, All Daily Online data set, is maybe the quintessential data set for digital humanities, at least in the English-speaking world. It's one of the largest projects that's completed. So what they did is, so they took, so Old Bailey is London's central criminal court, right? So everything that basically happened in this court is recorded in a printed form. and now it's digitized, right? So this is every single criminal court case from 1674 to 1913, right? So you'll see the context of this. And I mean, there was kind of a market for this as well. So people liked to hear about what was happening in the courts, almost like tabloid, literally. So there was actually an industry printing this stuff, right? So, but it also is very interesting because it gives you sort of evolution of law itself, the English law. How, you know, in the beginning, people would just sort of, you know, bring guys that do stuff, bad stuff, and say, what should we do with this guy, right? It sort of starts like that, and it really evolves. And you know, there was, you know, death penalty for stealing handkerchiefs, almost, right, in the beginning, and then it, you know, death penalty is abolished, right? So you can actually see the English legal system go through literally the Old Testament. You know, takes 100 and some years. Old Testament meaning a tooth for a tooth argument. So if I steal a handkerchief, maybe I'll slap you, not kill you. You know, all the way down to this New Testament, which is like, you know, if you slap this cheek, show the other cheek. So pretty much no death penalty. I mean, this is my interpretation, right? You can see the law and the penalties and the crimes evolve. And of course, it's in sync with the colonial penal colonies. So U.S., America was a penal colony of Britain in the beginning. And you can see, you know, people being sent to penal colonies because it's cheaper than putting them in prison, right? And then when America became independent, you'll see like the same sort of Australia was a penal colony. So anyway, there's a lot of history here. So here is the website. You can sort of get into it. And this notebook came out of a workshop I gave in King's Digital Lab, KDL, in King's College London. It's kind of the birthplace of digital humanities, I would say. Yeah, so and then I worked on this data set. It's just a preprint a while back. So it's a non-parametric view of the civilizing process in London's Old Bailey. So it's a non-parametric statistical view of the process. So what we basically did is, and this is what we will parse from XML today. So forget about all these multiplications and additions, but basically what we did is we took the data where, you know, where we simply look at these things. So there's offense categories and punishment categories, right? So offense 1 is breaking peace, offense 2 is damage, deception, killing, miscellaneous, royal offenses. Royal offenses would be like if you go to the forest, you know, demarcated for the royal family and poach an animal because it's for their hunting, for example. So of course, royal offenses evolve in time. Sexual theft, violent theft, etc. And then the punishment categories are not guilty, corporal death, prisons, no punishment, or transport. Transport is usually to a penal colony. Okay, so this is essentially, and I'm basically looking at these tables, right? These are just what, you know, how many people committed a particular offense and what was the punishment that was given to them, right? Just a count table. And these count tables are a function of the time interval, so you can look at every year or every month or whatever, right? So I'm trying to just understand these counts through time, right? There's no natural language processing or anything yet. Okay, so we did some Markov models and blah, 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 but you know, what we basically find is highly time inhomogeneous patterns, right? So this is just the raw data. So, you know, if you look at different offenses, you know, they change in time. And the same with different punishments, also change in time, of course. And so, you know, you can get plot of the offense probability estimates per offense for the best model. So we did some model selection and things like this. But don't have to get too deep into this because this is kind of done. And let's see. Yeah, what I wanted to show you quickly is, so after we did some model selection, we can get these kinds of things. So our Markov models are allowing us to essentially play with the conditional probabilities. You know, what's the probability of being, so here, for example, for the best model, offense partition model, that was varying every 3 years, we are able to say stuff like this. in 1674, the partition with the blocks sorted by the probability of death. So if you did a damage or killed someone or did a sexual theft, violent theft, any of these offenses, you got death as a penalty with almost 40% probability, and then for another 16%, you got death for even like poaching, okay, miscellaneous, I don't know, stealing bread. So it was pretty rough, right? So you got kind of killed with a very high probability for and then it evolves, right? So and eventually only if you kill you get death penalty in 1911. So anyway, this is just a lot of structure in the data. Okay. So of course, my sort of invitation is we'll sort of do some XML parsing in a hurry. So if you are on the community edition, to be able to do this, there's sort of two options. So it's in the stuff in the bottom below, in this download section. So you can download either the tiny data set or the full data set. So I recommend just downloading the tiny data set if you want to just parse with XML, because the full data set will take like 20 minutes and it's only worth it if you're interested in doing a project. Okay. So here is basically the full data set, and here is the wget for the tiny data set. Okay. So tiny data set, I just took some files from a few random years. Okay. But you don't need to do this now, just to be able to quickly follow. Right. So once you downloaded the data, you should have these two directories here. And so it's ordinary accounts and sessions papers. And inside ordinary accounts, you have this sort of by year. So it's a time-stamped thing. And session papers is, again, time-stamped XML files. So now what we can do is just use the whole text files method to read the stuff. And so that'll just give you an ordered pair of strings, the file name and the content. And so that's basically this. And now I'm just taking the second element of raw, which is the content. And now I'm simply getting the string, the XML file itself as a string. And that's what I'm showing here is now an RDD of a string. And here is the contents of it. Okay, so this is pure XML. So now if you want to do this in XML, so there's a whole XML library for Scala. So I would simply load the string into a scala.xml object. So now I have a Scala XML element. So now I can manipulate this element quite nicely in Scala. So here's just Scala XML element. And okay, I literally came to this point. Well, actually, I had no idea how to do XML. So what I basically did is a very, very quick preparation. So this is an excellent source. So it just gives you quickly the syntax. It just tells you how to pull various nodes and descend into attributes and elements and so on. So I just quickly looked at this, and basically that's all I did. And the other way to go is go from XML to JSON, but I haven't really tried it because I could do all of this here. So my parsing problem is simply finding the input tables for that paper I showed you, right? It's just pure extraction of the actual counts. So this thing basically, allows me to get types of div0 nodes. Okay, so this gives me the only div0 node is the sessions paper. Okay. So this is the thing in the very outside. Okay. So I need basically going into the first node into the body. So it's the div0 node. And because it's kind of organized like a tree, right, with different nodes. And so now I wanted to do this quickly. So here's my div1 node. So now at the div1 level, I have several nodes. Okay, there's well, several types of nodes. So I have front matter, one type, and then there's something called trial account and supplementary material. Okay, so now I can look at just div1, and it just gives me all of these the node sequence with div1. Okay, so I mean, if you look at this, it's a lot of information, right? So on the King's Commission of gold delivery of Newgate, blah blah blah, on Wednesday, Thursday, and Friday, person's name, so judiciary's name. There is a surname of the different defendants, and and there are people that are only do this for a living, basically, right? So there's a bunch of people in Germany and England that do this stuff. So all I want you to realize is that every single statement that was uttered in the court by who, all of that is documented here. So it's super detailed. So now I'm simply interested in, say I'm only interested in pulling the trial accounts and the ID of the, right? So this gives me my, I'm just getting the type of the node and the ID of the node. And here, okay, this took me hours to do, so I'm not saying this is easy, but you can do it, right, once you figure it out. So I have to descend in the right way into the tree. And what I'm trying to get is basically, offense category, offense subcategory, what are the type of these offense categories and subcategories, and punishment category and subcategory, right? So these are exactly what I want, and then I convert that to a set. So this is just a Scala set, and this will give me a set of wanted fields I want. So now I simply have to turn this into a count, right? So I have to do a reduce by key, and then I'm doing all of this as a JSON string. So what I'm finally getting is, there was one theft, it was not guilty, and that's the ID of the case, and so on. So now I'm basically going to the right nodes I need to build my counts, and it's getting late for Fika. So I'm basically able to find the counts that I want. And here's the full ETL operation. So this is extract, transform, load, and I'm going to remove it. And finally, I'm going to write my trial counts into a file. This will take a little bit. We'll go get Fika. And what you will finally find is this nice table. Okay, so I can get timestamped counts of the punishment, and this is my input to my parametric mode. So this is mainly to get you guys brave into XML land, and there's a lot one could pull out. For example, what the defendant said, for example, in each case, and and we can get into more deep learning methods and do long, short-term memory, whatever standard methods for processing text that are out of the box here. You can apply those things. Okay, so let's get some Fika now.
Can you post the notebook in it?
Yeah, so
can you post this Git, the notebook, this one?
Yeah, so the notebook is there, right? So you can upload it from the latest DBC archive.
This one not there.
It's not.
Really? Oh, right. Oh, yeah, true. Sorry. Yeah, so I haven't pushed anything. Oh, I'll push now.